Hi everyone, today we will discuss potential and the potential difference. So here you can see, just to understand this potential, basically this potential, it is defined to bring unit positive charge from infinity to that point. So let us say we have this electric field region, unit positive charge from infinity to that region. So from either you can say infinity, which becomes a hypothetical assumption, or you can say from a very large distance. A unit positive charge, it is brought from infinity to that point, means any point of this electric field or electric region. So let us say it is brought from this point. Okay. Now the work done in bringing this unit positive charge from infinity to that point or any point of the electric field or electric region is termed as potential. Work done in bringing unit positive charge from one place to the another place, but one place is supposed to be what? Infinity. Now why do we consider this infinity? Is just because if it is the larger distance, then the potential at infinity, it is supposed to be zero. So it means generally zero or origin, it is taken as a reference point for any consideration of any physical quantity. Here also, to make the potential zero at any reference point, we take that point at infinity, because potential at infinity, it will be zero. So when potential at infinity is zero, so that becomes our reference point, and with respect to that, and that's because of that only we have this kind of definition, that work done in bringing unit positive charge from infinity to that point is termed as the potential. So let us say we have this unit positive charge and it has been brought to this point. Okay, let us say this point P. And the work done in bringing this, it is suppose W1. Similarly, work done in bringing unit positive charge to another point in this region, let us say it is Q, so it is W2. So work done in bringing charge from this point to this point of any electric field or electric field region, it is W1. From this point to this point, it is W2. Now, this work done in bringing unit positive charge from this point to this point, that is termed as potential. And potential, it is measured in volt, and that's why we consider this potential, which is nothing but the work done. Work done, it is a scalar quantity, so potential, it is also a scalar quantity. Unit of potential, it is volt, so we represent generally by V. V stands for volt. So instead of this W1, if we can write it as V1. Similarly, instead of W2, if we can write it as V2. V2 is the potential or the work done in bringing unit positive charge from this region to this point. Okay, from infinity to this point. So that is assumed as suppose V1. Here it is V2. Now, as work done or potential, because potential is nothing but the work done. Work done is a scalar quantity, so corresponding to that potential, it is also a scalar quantity. So work done in bringing that unit positive charge from this point to this point, that will be equal to how much? Either we can say V1 minus V2, or if it is brought from this point to this point, then it will be V2 minus V1. So work done in bringing positive unit positive charge from point P to Q, that will become V1 minus V2. So unit positive charge, this clear, and that is V1 or it is V2 from one point to the another point. This is with respect to infinity. Here potential is how much? 0. So you can consider this is V1, this is 0. So from this point to this point, it becomes V1 minus 0. From this point to this point, it becomes V2 minus 0. But from this point to this point, it becomes V1 minus this V2. Is this clear? So now this V1 minus V2 potential in bringing unit positive charge from one point to the another point, that will be equal to potential at one point minus potential at the another point. When we say the potential, so that potential or that work done is always compared with respect to a point at infinity, because potential at infinity, it is supposed to be 0, so that point is taken as the reference point. Now here from this point to this point we are getting V1 minus V2. So this is work done. This is work done in carrying a unit positive charge from one point to another point. This W1 or this V1 is work done in carrying unit positive charge from infinity to this point. Again from infinity to this point, that becomes V2. So we are taking the charge as 1 from one point to another point, or either from this infinity to this point or from infinity to this point. So that is work done. So from here can we say work done in carrying Q amount of charge from one point to another point, that becomes what? Work done in carrying Q amount of charge. Unit amount of charge, it was V1 minus V2. So Q amount of charge, it will be equal to how much? Q into this V1 minus V2. Q into V1 minus V2 from one point to the another point. Work done, it was V1 minus V2 for unit positive charge. So just using the unitary method, you can see it is Q V1 minus V2, because these are all scalar quantities. So we don't have to bother about the vector addition, subtraction or anything. So it is just Q into V1 minus this V2. This is work done in carrying Q amount of charge from one position to the another position. Now let us come back to this. This potential, we use the word potential when we compare the potential or the work done with respect to point at infinity. And one point it is at infinity, another point is in this electric field or electric field region. When we compare work done from the infinity to one point, that work done is termed as potential, because another point is having the zero potential. But when we consider this work done from this point, one point to another point, and that we get V1 minus V2 or V2 minus V1, so that will be termed as potential difference. Here this is finitely located at this point, this is finitely located at this point, and this was located at infinity or a very, very large distance. So very, very large distance, so potential here it is 0. Okay, potential with respect to this point here it is V1. So that potential with respect to origin or here it is infinity, that we call it as potential, taken as an absolute quantity, because it is compared with respect to 0. But when we compare with respect to one point and another point, so there we don't say the word, use the word potential, we use potential difference, because this point is having some potential, this point is also having some potential. So work done will be either this potential minus this or this potential minus this. So that becomes your V1 minus V2. But this V1 minus V2, it is still for unit positive charge. So this is the potential difference in carrying a unit positive charge from one position to the another. Now if instead of unit positive charge, if Q amount of charge is carried from one point to the another point, so that will be equal to, for 1 it is V1 minus V2, so for Q it will be how much? Q into V1 minus V2. So this becomes your work done in carrying Q amount of charge from one position to the another position. So we have three words here. One is the potential, another is potential difference, third is the work done. Potential, when you compare the potential of a point with respect to origin, so we don't use, that is also a potential difference, but we generally use only potential just because another point is supposed to be located at infinity, its potential is 0, so V1 minus 0, it will always remain V1 comparing with that point at infinity. So we use the absolute word potential, not the potential difference. But from one point to the another, that work done, it will be termed as the potential difference, because every point it will have its own potential. When we carry a charge from one point to the another, so it will depend potential difference between those two. So it is V1 minus V2. Now V1 minus V2, it is for the unit positive charge, but when we carry Q amount of charge from one position to the another position, so this becomes Q V1 minus this V2. So work done is equal to charge which is carried from one position to the another position, and that becomes Q V1 minus V2. So here, just to summarize all this, V is your potential, unit is volt, that is compared with respect to point at infinity. VPD, that is potential difference, that is always between the 2 points which is located at finite distances. So that becomes your potential at one point minus potential at another point. So V1 minus V2. Work done, that is W is equal to Q into potential difference between the 2 points. Work done in carrying a charge from one position to the another position, that will be called Q into potential difference between those 2 points. All these are scalar quantities, so we don't have to bother about other additions like the vector addition, subtraction. So it will just follow the simple algebraic addition, subtraction, multiplication or subtraction. I hope this is clear. Now if we try to understand it in more elaborative manner or using some calculus representation. So here you can consider a test charge Q naught placed in an electric field E. Then the force experienced by this Q naught, it will be how much? F is equal to QE. I hope this is known to you. This we have already discussed. Force F, it is equal to Q into E. This is the force and this is the electric field strength. So that gives us Q naught into this E. Now work done in carrying that charge for a small displacement, suppose ds. So that will be F dot ds. Work done, that is F dot displacement. So F dot ds, that is equal to F will be replaced by Q naught into E, so it is Q naught E dot ds. So this becomes your work done for a very small displacement, and that is ds. Now change in potential energy. This change, because work done, potential difference, it is nothing but the work done, and work done is what? Potential energy. That's why we are using this word. Change in the potential energy, that is equal to dW. du, U stands for the potential energy, W stands for the work done. So du is equal to change in potential energy, that is dW, it is equal to Q naught E dot ds. Q naught E dot ds, because F dot ds, that becomes work done or the potential difference. So Q naught E dot ds. Now you can see this minus sign here, minus of Q naught E dot ds. That minus sign is only because we will be moving against the field. When we are moving against the field or against the electric lines of forces, so work done, it will be negative, and that's why it is minus of Q naught E dot ds. Now, so here this becomes your du or dw, that will be equal to minus of Q naught E dot ds. Now for finite displacement of the chase charge between the points A and B, so this initially we were considering what? Infinity as the reference point. Now if we consider the finite distances or the points located at finite points, as we have already discussed, so suppose those points are A and B. So potential at B minus potential at A, because this is also change in the potential energy. So potential, now the same thing, it is elaborated for two different points. So UV minus UA, delta U, and delta U for what? Points A and point B. So that will be UV minus UA, that is Q naught E dot ds, Q naught E dot ds. Here you have minus sign, so this will be taken out of the integration. But this will be integrated from which limit to which limit? From the point A to B, because the positions are A and B. Charges will be moved from point A to B or from point B to A. So it is A to this B. Now the potential difference VB minus VA between the points A and B is defined as VB minus VA, that is equal to A to B E dot ds. They are the same thing. E dot this ds, because now here it is Q naught E dot ds, that was the work done, that is potential energy. Now potential difference, when we consider the potential difference, the charge is what? Unit positive charge. So this Q naught, it will be replaced by what? 1. Q naught, it will be replaced by 1, because potential difference we considered for the unit positive charge. Work done in general we considered as W is equal to Q into potential difference. So when we are so this was your work done, this is your potential energy, and that's why we have the term Q naught here. But if you consider this potential energy, instead of potential energy, the potential difference, that is the only basic difference, because potential difference, it is considered for unit positive charge, work done, it is considered for Q amount of charges. So that becomes what? Minus A to B E dot ds, and Q naught we are taking as unit positive charge at the test charge. So this is your potential difference in general between the 2 points A and B, that is integration of E dot ds with the minus sign. This minus sign only indicate that we are moving against the field or against the electric lines of forces. So again we are coming back to this definition that for unit positive charge, work done for unit positive charge. Now why this unit positive charge? Because we have taken this Q naught as 1, and that's why for unit positive charge, and that is termed as the potential when the charge is carried from infinity to that point. When it is carried from one position to the another point, the same potential, it will be termed as potential difference. When it is for the Q amount of charge, displacement for Q amount of charge from one point to another point, that will be termed as work done. So potential difference, work done, they are all similar to each other. All are work done. Potential, it is with respect to infinity, that's why we use the absolute word potential. Potential difference, it is from one point to the another point for unit positive charge, so we use potential difference. For one point to the another point for Q amount of charge, that becomes Q into potential difference, and that is the work done or the potential energy. So I hope this is clear. Now corresponding to these terms, we have certain units that we can just discuss. Electron volt. This unit of energy is commonly used in atomic or nuclear physics. Electron volt is the energy, an electron or proton, because charge on electron or proton, it is same, only thing is nature, it is different. An electron or proton gains when accelerated through a potential difference of 1 volt. So when this electron or proton is accelerated through a potential difference of 1 volt, that is again unit potential 1 volt. So 1 electron volt, that will be equal to how much? Because charge on electron, it is 1.6 into 10 power minus 19. So 1 electron volt, it is 1.6 into 10 power minus 19 joule, that is equal to your 1 electron volt. Kilo electron volt, that will be multiplied by 1000, so 10 to the power q eV. Mega, that is 10 to the power 6, and so on. Nano, it will be 10 to the power 9, and so on. So that way we can consider all this. Potential gradient, if you consider potential difference, we have represented what? E dot ds. So in general we can write E dot dx, where dx represent your small displacement. Corresponding to this small displacement, we have this potential difference dV. This is again, there was the minus sign. If you have we have just observed that minus sign, because we are moving against the electric lines of forces or the field line. So we will get this as dV is equal to minus of E dx. So we can represent like this. Now the same thing, if you represent like this, E is equal to minus of dV upon this dx. So this is termed as potential gradient. Potential gradient. So minus of dV upon dx, that becomes your potential gradient. E is the electric field intensity or electric field strength. So that way, so E is equal to minus of dV upon dx. This can be represented as dV is equal to minus of dx. Now whenever we come across certain relations where variables are concerned, then we use these relations to further move on and simplify that question. So this is your potential gradient, this is electron volt, which is nothing but the unit of energy. And these are your conversion factor, that is 1 eV is equal to 1.6 into 10 power minus 19 joule. So this way we can define. So we will start simplifying problems based on concept, that is we have discussed Coulomb's force, we have discussed electric field, we have discussed electric potential, we have discussed these units electron volt, as well as we have discussed potential gradient. And we have discussed all the electrostatic unit ESU. Similarly, corresponding to that, we have discussed the value of that K constant used in Coulomb's law. So we will be starting simplifying problems based on this concept of electrostatics. Thank you.